What is this? What does this mean? What is the relation between x and y? Y is what of x? Is y exactly like x? Is y is superset, subset of x? Superset. Okay. And y has deny and x has accept. Traffic come in. Distant to rule x, or traffic come in to this particular IP address. 3340 going to 2740. What will happen to this traffic? It will be denied because y comes first and we have to go sequentially in the matching. So y will be hit before x. That means x here is useless. So every time you go and complain, I don't receive my traffic. I don't see anybody. My web traffic is inaccessible. My web services are inaccessible. What is wrong? You go to your policy. You check your policy. You will find a rule say for this web traffic should be allowed, but you overlooked your policy and never know that there is a rule somewhere in the top of the policy that's in a superset of this rule. The shadow, we call it shadow this rule, that makes this rule basically useless and ineffective. And this is one type of policies that you might have, one type of conflict that you might have. Correlation, an example of correlation like this. X and Y are two correlated rules. Now, if they are two correlated rules, so what? What's the problem with this? Well, the problem here is related to the intersected area between them, the area which is common between them. Look, if X comes before Y, as we have in this screen, what will happen to this traffic in the white color going from 3340 to 2730? It will be denied. But if I just flip, make Y before X, this traffic coming to this white address space will be accepted. Now, this sort of ambiguity in the policy is really confusing. And we don't know which one is the right semantics. So the administrator has to be notified about this. By the way, you have two correlated rules. And these correlated rules, there is no one meaning that might be logically always true. So which one you mean? It is something that introduces ambiguity. And this could be classified as also as a conflict. Generalization, I'll skip that because it's not really a conflict. Redundancy is a problem because redundancy means two rules or multiple rules have the same meaning. Why you have them in the same firewall if they have the same meaning? If this rule Y, rule X, have the same meaning, why you have them there? Actually, they have harmful results in your firewall because the more rule you have, the more matching and the more your performance will be degraded. So we need to remove redundant rules. Well, that's a very simple argument. So why we didn't remove them? Because we have to be careful. What do you say about rule X and Y here? Are they redundant or not? X and Y.
Not necessarily. I mean,
yeah.
It depends whether, on the ports, because especially when you're looking at the ports, if you're looking at from port any to 53, you might have applications that utilize more than the 53 port at that point. If you want to keep the ports open for that, for more than one thing.
You are kind of looking behind these two rules, right? And this is correct. Look at this. If you look at these two, you're definitely going to say, one of them, I can remove X because X is a subset of Y. And if I take out X, there's nothing changed in my policy. I still have the same behavior in my policy because actually X is a superset, X is a subset of Y, and they both accept. But as our friend just said, I cannot do that. Maybe there's somebody else is having a different range is using it. So what if I have Z in between here? Z is a rule that comes between X and Y. Now this makes X and Y are both mandatory because X is a subset of Z and Z is a subset of Y. Even for this simple relation, redundant, it is not easy to remove as we imagine. You just go and look for two similar rules and remove them. I have to look at redundancy in the context of the entire policy. This Z coming in between makes both of them necessary and makes the policy has a different semantics. And this is what I just want to draw your attention. Even the simple one here is not simple. The last one is irrelevant, and irrelevant means and this is very highly exist in firewall today. Some rules, they are sitting there and never been activated. Why? Because actually the firewall sits in a completely different network, or the IP addresses is not correct. It has been moved from one network to another, is misconfigured, and this we call irrelevant. The firewall will never use them. These kind of conditions, or these kind of conflicts, or you can say it misconfiguration, now is being formalized algebraically in this format, and that has a meaning. What is the meaning of this? Now I can build a simple tool that takes this kind of formalization and just process my policy and automatically find out all kind of conflicts or misconfiguration in my policy without any human or manual inspection of the policy. And that's really the goal of this, to come up with a formalization that's theoretically sound, so and also performance-wise is doable, so we can run this verification on time. Now, this is looking at one single firewall. What if you have multiple firewalls like here? Do we speculate any kind of conflicts between firewalls themselves? Okay, we know there could be a conflict between rules in the same firewall, but is there a conflict could happen between rules of different firewalls? Yes. One firewall might say, allow a traffic. Another firewall might say, deny this traffic. What will happen here? If a firewall, we call it upstream firewall, say deny. The downstream, close to you, your host firewall say allow. The traffic will be denied, regardless if you say allow or not, in your downstream. And this is called shadowing, because my upper hand firewall say deny, and that means I will never receive this traffic. I want this to be clarified. Who is correct? Is it the downstream or the upstream? We have to identify this problem first of all, and then we solve it. The opposite might happen. What will happen if the reverse, the upstream firewall, close to the enterprise, close to the internet, for example, allow the traffic, but your firewall in your enterprise deny it? So the traffic goes into your network, travel into your connections, goes all the way to your machine, and is being denied. This is a waste of bandwidth. We call it spurious traffic. This could happen all the time in enterprises, and this could be a potential of denial of service if I have a lot of, if I have, what is that? Do you have a cat here or something?
Maybe.
Okay.
We have run out of time, so if you want to take a minute or two to summarize.
To summarize, sure. So if we want to allow a system administrator to look at this problem and manually inspect it, it's just going to be incomprehensible, because he will not look at an enterprise of 3 firewalls, but you might have hundreds or maybe thousands of firewalls exist in the same enterprise, and you need to analyze them in an automated way. This is what we come up with. 16 conditions. How many conditions we have in a single firewall here? We have about 7 conditions in a single firewall. And what we said before that is a union of this. If you can make sure that every one of these conditions doesn't exist in your firewall, that means your firewall is correct, or your policy of your firewall is correct. Here we have 16 conditions. These conditions, each one of these conditions is to determine one conflict that might happen between two different firewalls. I talked about shadowing, talked about spurious, redundancy is clear to you, I guess, intuitively clear. Let me drop all the way to correlation here. What correlation between 2 different rules in different firewalls might lead to? It will lead to shadowing or spuriousness. This is shadowing or spuriousness. And I hope you understand at least the meaning of spuriousness or shadowing. Shadowing means you are not getting the traffic which is you